All right, are we coming through? Can anybody hear me? Raise your hand if you can hear me. Wow, everybody's paying attention. That's awesome. All right, so we're going to dive right in because I honestly have no idea how the timing of these slides is going to work because I changed them all between the hours of midnight and 3 a.m. last night. So Ash Framework is a resource-oriented declarative design application framework. And in this talk, we're not really focused on teaching you how Ash works or how to use it. Instead, we want to highlight some problems that exist in the real world and how you can solve those with Ash. I want to talk a little bit about our community growth. It's good to highlight this. We've had really good success since we moved our community support efforts to Elixir Forum. We were kind of hidden in a Discord server for a long time, and early on we had something like 30 or 40 people in production, and somebody asked on the Elixir Forum, is anybody actually using Ash? And it's that we were hidden in our own little Discord server. So ever since we went on to Elixir Forum, we've had a really good uptick in sort of visibility, and that also helps with support because these are searchable. You can find answers to your questions. And we have a Prog book coming sometime soon. You know how timelines with these things work. I'm not going to give you a timeline, but we've got an editor, we're working, it's going to happen. I'm going to start with the story of a function, and really what we're looking at here is how these things grow as we build more rich domain operations in our system. So this is a baby function. It's very beautiful. If I see this function, I'm like, great. I know exactly what this does. There's no confusion. It's very simple, and it's wonderfully easy to understand, and that's a very important quality of our domain operations. This is a toddler function. It's still simple, right? I don't think anybody would look at this and be like, oh, that's so complicated, I can't figure out how it works. But I'd say it's already, right here, it's heading towards a troubled childhood. So this is an adolescent function. It's very rude, it's very unpleasant, and it talks back to its parents. And what I mean is that this function has a lot of opinions about the world, right? It expects to get options in a certain way, it expects to get arguments in a certain way, and they're semantic, they have meaning. They're not just, small flags and there's a typo in that function, but don't worry about it. And this is a grown-up function. It's cleaned itself up. It's got a suit and tie, it's got a job. I would argue that its potential has been wasted, however. There are millions of functions like this out there. And the truth is this is not bad. I don't come to a code base if I have to help on something. I don't see this function and think, oh my God, what were these people doing? This is crap. That's not the case. But I do think that we can do better, and that's essentially the theme of this talk. So I'm going to talk about imperative versus declarative, and it's important to clarify the terms here. When I say imperative, I'm mostly referring to in contrast to declarative, right? And we'll go through kind of what I mean by this here. So imperative is code, declarative is data. Imperative is instructions, and declarative is stating the end result, right? So an example here is telling your child, pick up your toys, put your laundry in the hamper, and make the bed. Or telling them that your room better be clean when I get home or there'll be hell to pay, right? So it's important to understand here that this only works if your kid knows how to clean their room. So it requires smart tools that know how to take higher level instructions and are already aware of how to do the lower level thing. So saying write declarative code is not a useful instruction on its own. It requires writing smart tools that you can give higher level instructions to. And this is, I think, a matter of opinion, but I would say that imperative versus declarative is relative. It changes over time as our applications get higher level and as our abstractions get higher. So, not that long ago, this would have been the conversation being had about imperative versus declarative. That this for loop is imperative because you decide, you initialize a variable, you increment the variable as you go, you explain to it how to go from the first element of the list to the last element of the list. And enum.map is declarative. You don't tell it how to iterate the list, you say, do this for each thing in the list. This is another example, and this is an example from Ash. An imperative version of authorization might look like this, where we have a function and we say, we check each of our checks, we do them in order, and we return what we want to return. And again, this isn't bad code, But in Ash, we have policies, and these look really similar. You read them like a workflow, but these are data. They are not code in the sense of this imperative example. So for example, these policies are actually data. We build an expression that represents the facts about this authorization attempt. And we, at some point, turn it into that. It's actually an internal representation of what that statement is. And that is passed to a solver that gives us back scenarios by which these are true and false. Now, I could explain Boolean satisfiability solving. That's a whole talk on its own. But the important point is that you can't turn this imperative bit on the left into instructions for a solver. So you are limited, ultimately, in your options. But when you are using data, you are free to make whatever transformations you want to make and free to solve the problem in a different way than you could have otherwise. Yeah, you see the two next to each other. And look, there's a lot of middle steps here, so it's not literally a one-to-one between those two things, but So I want to talk about artificial constraints. And imperative code imposes artificial constraints. And it's best to show this by example. Trying to explain exactly what I mean, it's better to show with example. And what I would say is that this kind of problem, we see it everywhere. And once you see it, you can't unsee it. You start asking yourself, is this a rule of the problem that I'm solving, that it must be done this way? Or is it the way that I solve this problem that is the cause of maybe the optimization issue that I'm facing or what have you? So let's go through some examples. Order matters. This is an example where we fetch a tweet from the database and we compute some property and then we compute some other property, right? And it's hidden from you looking at it here, but this computed field 2 is derivative of computed field 1. So if you were to come in and just change the order of these, you would have a bug, right? Now you don't have to write your code this way, but in this example, that is what we're looking at. It's not a rule that when computing properties that depend on each other, you have to give it an order to do it. That is an implementation detail of the fact that we used functions, one function per computed property, that they require to be run in this prescribed order. Simple or optimized, pick one. This is just a truism in engineering, right? Here's an example where we are adding where we have our tweet query, and we want to add two conditions. One where the tweets are only for active users, and one where they're from the friends of the current user, right? So this might be like my homepage for me, from my friends. And if you'll notice, each one of these little things is for active users and from friends of. They join to the user table. So technically, this is not as efficient as it should be if you were to just write this by hand. And honestly, that's not that big of a deal. I would probably not say you need to go refactor this because you're joining to a table that assumingly has an index. But it's still, you have to make that choice. And not all problems are like this. Sometimes that optimization matters. And in order to get the optimization, you have to go from something super simple to something wildly complex just for the sake of an optimization. Here's an example of how you would optimize that using Ecto, or one way that you might optimize that using Ecto. So I know there's a lot of code up there, but the important bit is we check before we join if the thing has already been joined with that name, and if it has, we leave the query alone, and if it hasn't been joined, then we join. Now we've got our optimized thing. Both of these things can be used independently, but there is a problem with this. This is what I would call an accidental language. So there are semantics hidden throughout these functions. This constant, local constant, friend link is not just a reference to a table. It's a token in our optimization language that we just wrote. And so if you wanted to change that, you're not just changing something cosmetic. You have to change it everywhere that you use that thing. And it's easy to see when it's like right next to each other, but a lot of times these things sprawl and they spread out, and you have this language that is spread out across your system, and that's okay. It's okay to have these kinds of languages, but it's not okay to have them accidentally. They should be designed as part of what you're building, and we'll see some more on that here soon. Closed to extensibility. So we have these three functions, and let's say we want to emit a log event, we want to send some analytics event. There's a million things that you often want to do that's a cross-cutting concern across various operations in your system. How would you add it, like a statement in here, that logs to your analytics platform that every time a user is created, updated, or deleted? You put code in each one of these, right? You will alter all three of these operations. And that is what I would call closed to extensibility, insofar as you must physically alter each thing. They aren't extensible in you'll see what I mean. It's hard to explain. So single-use functions is, I think, another good example, right? Let's say we've got a full name function that returns a user's full name. But we want to also be able to do this in the query. Maybe we have a search box that lets you search for a full name equaling some value. You can't put that Elixir function in a SQL query. It doesn't work that way. So you have to duplicate the logic of what full name is in your system in two places. And if these are your only tools, you do not have another option. You can do some cosmetic things. You can make a macro called full name so that at least they are named the same thing and it's not quite so confusing. But they will be two different things. You will always have the version that does it in Elixir, and you will always have the version that does it in your SQL query. Now, whether or not you want to do search on full name is your own problem. And I would say they have limited composability. Now, we compose our applications we compose the different parts of our applications all the time, but functions are essentially fences, or you might have heard that as like an optimization fence, where when you invoke a function, the function goes all the way to the end of it. You can't interrupt it, you can't alter it, you can't modify it. It's not data, it's code. And in this example, we have 4 active users, and we have from friends of. And both of those add a where clause. But what if I want to say where it's for an active user or from one of my friends? That's a valid, I think, query that you might want to make. So maybe you do something like this. You use or where. You make a new function called or for friends of, and you use or where. Now, there's a bug in this code. It's pretty subtle. I'm going to give you 10 seconds to find it. You raise your hand if you find the bug. What's the bug?
The new condition is going in or with the existing one, so it's returning more results.
That is a potential bug, yes. But there's a different one. Yeah. Okay, there's 2 bugs with this code right here. All right. So the one I was getting at is this or for friends of calls join friend links, which does an inner join. So you think you're saying where it's from one of my friends or it's some other condition, but it's technically it's from where I have at least one friend and it's from one of my friends. So this has a subtle logic bug because you have an inner join. And you have to then change, well, if I'm joining to a where, it has to be a left join. And that's theoretically an optimization lost because you want to reserve the ability to compose your components. So let's talk about Ash. I'm not really going to introduce to you how Ash works. There are other talks that you can watch. There's a lot of documentation. Instead, I want to show you those examples we just saw. I want to show you how we solve those with Ash. So order matters. Remember this one where you have to add some computed field to? In Ash, calculations express a dependency on the data that they need. It's part of being a calculation that you say, I need some other thing. And in Ash, it doesn't matter what order you put those in the list. We will solve the dependencies before calculating your values. And you'll see some more examples of calculations here soon. So again, you can solve that problem. And I would suggest that the second bit of code is not somehow like less readable. It's not worse to look at or less or more complex. So simple or optimized. How about simple and optimized? So these are calculations in Ash. We have a calculation that says, is this for the active user, or for an active user? And we have another calculation that says, is this from a friend of a given user? So these are expression calculations. They can be run in the database. And you can see we can compose them here for active user and from friend. And the internal, our filtering logic, is aware of if it needs to do an inner join or a left join, and you can say or and all different kinds of things. And we do the joining, and so we're going to make sure you only join one time. So because you aren't explicit about the joins, you're explicit about the logic, the condition, not the how to satisfy that condition, you don't have to worry about, is this simple or is this optimized? Yeah, only joins the users once. So we can talk about accidental languages. And I want to make it clear again that these languages, these little subsets of language will emerge all throughout your application. My only request is that you design them intentionally. You do not let them accidentally emerge. For example, these calculations. These calculations have explicitly named entities: for active user, from friend. The arguments are explicitly named, and you compose them with those names. There's no extra optimization content or references that you need. You refer to these things by name, and the underlying system solves it. Closed to extensibility. We showed this example where I'd have to add code to every operation in my system or build some other abstraction, right, that calls it, there's options here, but this is essentially the basic solve for this. And where in Ash, we have actions. Instead of a set of functions, we have a set of actions. And you can tap into every action invocation with a single line. So we have a set of global changes. And what this change track analytics event does is it runs this logic for every change that happens on the resource. And now we have a place for our cross-cutting concerns that does not require opening up each action and modifying it in some way. Single-use functions, we talked about this. We have our SQL-y version of full name, and we have our Elixir version of full name. So in Ash, we have portable components. We have portable expressions. So we have our full name calculation here that's first name plus an empty space plus last name. And I can filter with it, in which case I get a SQL query that does that logic. Or I can just run the calculation in Elixir. It's a portable calculation, it's a portable expression syntax that supports multiple targets, including Elixir and SQL. So I don't have to redefine full name to get the ability to reuse this in multiple contexts. Limited composability, we talked about how do I OR these two conditions that do an inner join, right? How do I make them OR? Well, in Ash, we have composable by design. Because you don't explicitly declare joins, you define these calculations, which are essentially logical expressions, right? When you use them, I can say for active user and from friend, or from friend, and Ash will, again, inner join when it can, because it knows it can, or it will left join when it doesn't know that it can. But we can even do more. We can use these as part of our, this is a valid expression that will get evaluated to a case statement in Postgres, which is if for active user, then it should be from one of my friends. And if it's not for an active user, then it should be from somebody who's not my friend. It's a crazy condition to put into your UI, but if you did, you can. We can use them in policies. These calculations that are express a domain concept, is this for an active user? We can use these to write our authorization code without having to redefine the logic behind that, and this is again portable. You'll see more on that in a second. So I can say if it's for an active user, then you're only allowed to see it if it's from one of your friends. We can use it in atomic updates. These are updates that happen in a single statement in the database. So I can say set the status to published if it's for an active user, otherwise pending. And this happens in the database as part of the single update statement that we make for the record or records. So I'm going to talk about Ash 3.0 now. How am I doing? I'm doing good on time. Nice. What I typically have done in the past is, nope, I don't want to call Mike. What I have typically done in the past is I want to tell you everything about all the cool things that we're doing. And the truth is, I code nonstop, like I'm sure a lot of people here do. There's tons of cool stuff, but instead of that, I'm going to talk about one thing that I am really excited about, and we're going to go a little bit deeper into that topic. So for that, that's atomics and bulk actions, and they're very closely related topics, and they're a critical part of Ash 3.0. So this is an action in Ash. It's called publish. It's an update action, and all that you can see what it does is it sets the attribute published to true. Now, this is a very simple action. You can do all sorts of cool things with actions. I mean, you can do anything with an action. But this is a very simple one, for example. And to call it, I might make a change set for update, and then given some post, and then I might update that post. But what if I want to publish many posts? Like I have a query of like all of this user's posts, and I want to publish them. And I don't want to run that query, get all the posts back, and then update them one by one, right? This is the case for things like repo.updateAll or But what I don't want to do is have to rewrite my publish logic to be designed to work differently, and that's what you typically have to do. If you have a publish one, you write a change set, like a publish change set, and then repo.delete, and if you want to delete all of them, then you have to rewrite it as a query and say delete all, or publish all of these, update all. So what that means is in order to do this, we have to be able to turn this into an expression. The expressions we showed you earlier can be lowered into the database, which means we can make an update statement over a query because it can be put into a query. So to tell you how we make that atomic, or to tell you how we make that an expression, I have to break down what that is, which is it's data, surprise. It doesn't really look like data right there, but it is data. It's a module that has some input parameters like the attribute and the value. And what we'll do is when it's time to run an action, we know what all of the bits that compose the action are. And if you're just updating a single one, we might opt to call this change function. That's like do this like a change set, like a regular in-memory option. But you can enrich one of these to say, actually, here's how you do this atomically, which is you set this attribute to this value, and that value can be an expression. It's only a value here because it's just set attribute. We're setting it to an atom. But what that means is I can say post, I can do a filter for where it's for the current author, and then I can bulk update with that publish action. So that same action can update one as a in-memory, or as given an existing post, or it can update in a query. And this is really important because while that's a simple example, and I'm sure you look at that and you think, well, I could do that with Ecto without really having to redesign the whole world, and you're right. But we extend this ability throughout all of the primitives in our application in Ash to make it so that you can do really complex things that are complex by necessity, not because Ash makes it complex. But you don't have to throw away the benefits of atomics. So validations, this is a validation that score is less than 100. And we actually can update that, and we put it in the SQL query that will set the score to whatever score plus 1 is, unless it's greater than 100, in which case the database will return an invalid error. And Ash is in control of that flow, so there's a lot of how we do that is an interesting topic, and I'm gonna remember that I have time to not get into it. And this extends, so it extends to validations, but it also extends to authorization policies, right? So let's say we had these policies. It says this is for a games resource, and we say that you're only allowed to read a game that you're one of the players of, and you're also only allowed to increment the score if you are not changing the attribute from 99 to 100. Super weird and arbitrary rule, but it's great for this example. We can embed the policies directly in the query to give you a single atomic update statement that is safe for authorization. It's authorized access. It will not produce invalid data. And so you can see we've embedded the increment score policy by checking if you're going from 99 to 100. And then we also enforce the validation. And then on the read action, we enforce that you're only reading things that you're allowed to see. And what that means is this one line of, well, it's 4 lines of code, depending on who you ask. But this one line of code is the entirety of the domain operation, which is update every game that I can see, incrementing its score if that's a valid score. And it happens in a single query to the database. And this is extremely powerful, and it allows for progressively enhancing our applications to support more. Now, if you don't do atomic callbacks, you actually get a warning. It's going to say, hey, I can't do this atomically. You have to tell me that it's okay not to. So you have to opt in to non-concurrency safe operations. You have to opt in to slower operations. And that is really powerful. And it's fine to do it. Sometimes it's not worth the squeeze to figure out how to write something as an atomic, and you're like, it doesn't matter. I know as a programmer this is safe, or I don't care if it's not safe, whatever it is, you can just skip it. But that capability allows us to do so much more without ever having to rewrite the meaning of our domain actions. So for a practical example, this is a recent event. We have a plugin called Ash State Machine. And what that does is it defines valid state transitions for a given record. So this might be like a package, right? You ship a package, you store a package record, and then you say, it's pending when it starts, and we can confirm that it shipped, and then when the user tells us it arrived, we can use the arrived action to move it from confirmed to arrived. And there was a built-in change that was part of a state machine that was available for a long time called transition state. And what that does is it checks the action that we're in, it checks the previous state, and it checks the state that you're trying to move to, and it makes sure, is that a valid state? Like, you want to enforce these invariants of your state machine. After we shipped 3.0, somebody came and they're like, hey, I'm getting this thing that transition state isn't atomic. It doesn't define that atomic callback. So any action where I use transition state, I have to say require atomic false. And transition state is not a trivial, I mean, it's close to trivial, but it has, a fair bit of semantics in it. And you would not ever typically invest the energy to write that into a SQL query. And you'll see, this is a simplified version of the atomic callback, but for us, it's quite simple. We have an expression that checks if it's a valid state. We have an expression that checks, does it have a matching state transition for this action? And then we build a single expression that will raise an error if you're doing something wrong. And that's actually quite easy for us. It's a relatively simple operation. And as long as you're using the tools that we provide, like this, you get this for free. And if you're not using our tools, if you're using your own thing, you just have to define your own def atomic. So you still get something, I think, quite difficult practically for free anyway. And this was the feedback we got on it, which is, I'm just going to read this. Thinking about this makes me realize that this is quite amazing. I would have never taken the time to make such an action atomic with just ecto. I maybe would have locked it if it were very important. Now it's just a drop in, don't think about it feature. So your state machines are safe for parallelism. They're atomic single queries. They perform better. You can bulk update your state machines. You can say move all of the packages into arrived. And if one of them doesn't match the variance, you're going to get an error, right? So this is really powerful capabilities that we unlock. And for the user, what they see is this action, just transition the state depending. They don't have to know that it is extreme, like they don't have to understand the details under the hood that make it exceptionally powerful. They get that for free. All right, how did I do? Do I have a lot of time left?
Great, yeah, we got time for maybe one or two questions. Anyone?
Thank you very much for the very interesting presentation. I slightly changed my minds about Ash, to be honest. But I have more general question about it. Do you think it's possible to not come into the same world where Rails are now? Because I see that a lot of magic under the hood. And isn't it a dangerous path?
That's such a good question. Thank you so much. Did somebody set this up? No. This is something that I say pretty often, but many people, probably people in this room, Elixir has an outsized percentage of us that are, very experienced engineers, right? This is just a statistic of the community. We've been bitten by high-level abstractions, and simultaneously, most of us are good enough at building applications that we don't tend to opt into high-level abstractions. And if the only sales pitch of Ash was that it makes building applications easier, right? If it wasn't for the things I was showing about how powerful it is, about the new capabilities that I think are unrealistic to get otherwise, then it would be a horrible pitch. It would be a horrible choice, right? It's both. It makes it easier, but it also unlocks new capabilities. However, high-level abstractions can and should have burned you in the past, especially if you did it in Rails. And I tell people, if Ash was written in Ruby and available for Rails, it would have been garbage. So we're not building on sand, right? It's an immutable language. I can't go change your variable values. I can't do any of this crazy wacky stuff. And the ecosystem that we build on is extremely sound, right? Ecto is my favorite piece of software that has ever existed. And Ash Postgres, that data layer is built on top of Ecto. So all those queries get from all the planning and the safety and every other thing that we get from Ecto. And when you need to do something special, you're not writing raw SQL or writing Ash. You have a middle layer, Ecto, you can always drop down in and modify our Ecto queries or anything like that. So the answer is, yeah, it's Elixir and the Elixir ecosystem and the VM that we run on that make it not risky like you would if you had some other language with this high-level abstraction that kind of takes control away from you. Plus just a matter of, I know that that's a problem and I make sure that you can get around it. I have had that same situation and I'm like, oh, I got to make a high-level abstraction. So I know how to make it not suck so bad.
Yeah, Thanks for that answer, Zach. That's all our time. Let's give him another round of applause. Thank you.